Well, hi, and welcome to my shop. Thanks for joining me here this morning. So, yesterday evening, just 12 hours ago or so, I thought I'd give this radio a good shot on shortwave. I'd try all the bands, put an antenna on it, and just see what it does in the evening. It's about 10 o'clock last night when I did this. And it turns out the radio does really well. It's receiving really well. It seems as if every band is operating okay. But there's a very distinct problem left in the radio. Oh, by the way, the 20-minute or half-hour listening session I did, I went through all the bands and stopped and listened to lots of shortwave stations. I'll attach that video to the end of this one so you can watch the radio operate. But there is a very distinct problem which has been showing up the whole time I've been working on it here. And this is this somewhat mysterious hum. It's not really mysterious. I think it's very, very indicative of a problem which is probably common in old radios. I've heard it before, never nailed it down, because it's kind of a funny hum. So here's how it goes with this radio. If you tune in a weak station, then there's no perception of a hum or a hum problem or anything. If you tune in a mediumly strong station, what you hear as you tune into the station is a bit of a hum, and then the station will come in when you tune it centrally and sound okay, and then if you tune out, the hum may appear on the way out again. If you listen to it very, very carefully on a medium signal, once you have it tuned in properly, and if maybe someone is talking or the sound, the program material is appropriate, you can hear a distinct warble in the sound. My guess is it's the same hum coming through in some other fashion. The same hum you hear as you tune into it. If you tune in a strong station, last night there were one or two very strong stations I picked up. The hum is dramatic as you tune into it. When you tune into the station itself, instead of getting nice clear sound, you get terrible garbling. It's really not good at all. So it's something that has to be fixed. So that's what I'm going after this morning. So let's think about this. Now, it really is leaping out at me that this hum has got to have something to do with the AVC circuit in the radio. When there's no signal, there's no AVC voltage coming back from the detector applied to the grids of the early tubes. When you tune in a signal, there's a DC voltage that comes back and is applied to the grids of the first couple tubes to reduce their gain. If that signal coming back has a hum in it, I think it would explain everything that's happening. So the first thing I'm going to do is I'm going to check the AVC line for hum and stuff like that. And we'll just go from there. And we'll just follow troubleshooting from there. The thing is, to hear a hum, there has to be a hum. The hum can't self-generate. It almost certainly comes from the power supply somehow. Yet I've got all these new filter capacitors in here. This one too. Did I miss something somewhere in here? Doubt that. So if you imagine that all this filtering in here, all these capacitors, that drum the hum completely out of the power supply, how could you ever hear any hum anywhere else? Where would it come from? Unless I'm mistaken about that and somehow a hummy sort of sound could be generated somewhere else in the radio. I don't know how that can happen. Well, actually, I do know how that can happen. You know how that could happen? It could receive the hum from out here somewhere in my shop and get some kind of hum signal impressed in a very, very sensitive part of the radio. But I doubt very much that's what it is. I'm sure it's inherent to the radio. So the process here is going to be looking at the schematic a little bit, getting sort of familiar with the AVC circuit layout, and then testing the AVC signal, looking for this hum right on the AVC line, and we'll just go from there. Possible causes of this, if I apply my imagination to this, what I imagine is happening is in the detector tube, in the diode part of the detector tube, when that part is utilized, the hum is introduced. And where is the hum coming from? The tube itself. Now this would make great sense in a radio where the heaters are fired up with just 6 volts AC. You have the AC sitting right there in the tube. But in this radio, the tubes are heaters are run with DC, filtered DC. So another possibility is the filtering of the DC running through the heaters is insufficient still. Something has happened and it's not sufficient. So that's another thing we can look for. Hummy heaters. And another thing we could do is we could assume perhaps the detector tube itself has a defect in it. Although I've tested it, we could replace it and see if that doesn't do something to this hum signal. So okay, I'm going to get myself set up here, get some equipment going, and we'll take a look for that that crazy hum signal on this radio. Okay, let's start with the schematic here. No, let's start with something I missed that's worth reading here. Let me just put this part up. It doesn't matter how many times you read these manuals, there's always something in them that didn't really come leaping out. Look at this paragraph right here under tuning. Extreme care must be exercised in handling or servicing the tuner. Location and lead dress of components and wiring are usually very critical. Parts, locations, and ground connections should be as originally made. The tuner was carefully aligned at the factory and should normally not require complete alignment under normal operating conditions. Of course, this is not normal operating conditions here. I've changed a whole pile of parts in it. Replacement of tubes, especially the 1L mixer oscillator, may cause some slight detuning. So what they're basically saying here is don't fool with that tuner unless you're a bold guy or you didn't read this paragraph. So now I did replace a bunch of capacitors down there. I think I put them in pretty much as they were. I don't think I switched any of the ground points. If I remember right, I probably don't remember right. That's okay. So anyway, I read it now. It's a little late in the game. So here we are. This is where I think the hum is coming from, in this area here. So you have the detector tube. You see the little diode there. Let's zoom in just a wee bit here. See the little diode there. So a DC voltage is building up in this wire, and the audio is available because of the rectification of the IF signal here. So this filter, I replace these with discrete components. I know exactly where these parts are. Is this the cause of the hum? Really not very likely, I don't think. Okay, then down here, you can actually see they've written AVC of that away. And the DC voltage is blocked at this capacitor. Could a hum come back? Well, we're hearing the hum. The hum's going forward out this way. How do I know the hum we're hearing is really just from the radio? I think we can be pretty sure of that, because the hum, if it were hum were coming from in here, I think it would be there all the time. It wouldn't be related to tuning and all that other stuff. So I'm quite certain the hum is really coming from back. It's being amplified back here and being made audible. That's my theory. We should look right at this spot and see what's going on with this voltage while we operate the radio. So that's where is a 1 meg ohm resistor, a 0.01 capacitor, one of the two 50 pico capacitors I put in, one side of the 47 I put in. I should be able to find this pretty easy. Look for the 1 meg resistor attached to one of these two capacitors. Okay, let's go do that. Okay, a 1 meg ohm resistor attached to the two capacitors I put in. Two capacitors are here. Resistor is here. That's a red. That's a 2 meg ohm. There's a 1 meg ohm resistor right there, tied to this terminal, tied to here. So this is the terminal we want to get on and measure and observe the DC voltage. Lots of wires right in here. So I'm going to put this on after the radio is operating, because we want to know if the scope is actually affecting the test or not. Put it like this, you can see pretty much see everything that's happening. We're going to tune in 6 megahertz, I just picked that at random. I'm just checking to make sure the radio is really set to 6. Sure seems to be. Let's apply some power. And we'll switch it on here. Oh, look at that. Can you believe it? Can you believe it? Radio's tuned to 6. Signal generator just a hair below 6. And there it is. Glorious. Now, certainly doesn't sound like there's a hum or anything there. Let's see if we can make this problem appear. And maybe I should hook up the scope first. So we want this on B minus. That's where's a good spot now for a B minus connection? To the chassis? My God, I've forgotten. So there's a nice chassis terminal there. By gosh, I've forgotten now. Forgotten if the power supply is grounded to the chassis or not. Okay, just a sec. I want to take a risk here. I want to know what I'm doing. Let me just take a peek at the schematic quickly and look upon the power supply here. Just bear with me 1 second. Just trying to remember. Yes, yeah, definitely on the chassis. Is it? No. Not on the chassis. Definitely not on the chassis. Get it right, Jim. Definitely on a B minus wire. And the B minus wire. It's going to be right in there. Oh my gosh. Put that on. Get my fingers in there while we're getting. It's barely on there. This is where you get a shock. Not me though. Okay, and then we're going to clip this right up in here. So what we should see on the scope, actually, is just a DC voltage. We're on DC, 1 volt, 0.5 volts. You can see something there. Oh, you can't see anything there. Make it a little more visible there. So that just looks like, I don't know what that looks like. Looks like noise, a little more sensitive yet. Okay, and my scope lead is on, it's on ×1. So it's not making any effect on the radio as far as I can tell. Good, let's tune this radio and see what happens to that thing. Wow, did you see that DC voltage come through there? I didn't have it tuned in very well. Well, we can ask ourselves a couple of questions here. One is, where'd the hum go? No hum yet, but I've got a kind of a weak signal coming in the radio. What's with that heterodyne tone that's swinging in and out of here? What is that? What I've thought in the past is that this is the IF oscillating on its own. And so there's a 455 oscillation going on in the IF. And as you tune the local oscillator, you bring one of the mixer products right across the 455 self-oscillating IF, and you get this effect. Oop. So much backlash in this tuning. Okay, so where now? So that way, there's another problem to think about anyway. Where's the hum? There's no hum there. Let me turn up the signal strength. That's 10 times higher. I'll tune through. So I didn't hear any hum. Can you see my hand turning this? You can't. You gotta be able to keep an eye on what I'm doing with my hand here. Just so you know what I'm doing. I'm sure there's times where I adjust the volume on radios and people don't realize I've done that and they mistakenly. Well, that heterodyne really marks the center of the tuning very, very clearly. I think my theory is correct. Now that's a pretty high frequency there. Let me just back it up a bit. So that sounds like, I don't know, 2-3 kilohertz to me. So that means it'd be 2 or 3 kilohertz. The local oscillator would be generating an IF product that's 2 or 3 kilohertz from the 455 to make that sound. I'm tuning the dial band. Yeah, that could be true. I'm on the 6 megahertz band, so a little, yeah. What I'm doing is I'm trying to rationalize the what was that? What is that? My cat's coming in on the radio. Peanut, are you in there? Peanut. I've lost him. Peanut's usually around 5.6 megahertz. Let me tune that in and see. Hello, Peanut. Calling Peanut. Peanut, are you there? We're not getting... Oh, I heard him. There he is. He's around 5.6 megahertz. Oh, there he is. Well, buddy. What? I already spent time with you today. What are you doing in here again? Wasn't that enough? Well, I'm in the middle of fixing a radio. Yeah, I know. That's right. Go find Shadow and have a play. Okay? Yeah, this is his playtime with me. But I'm a little bit busy at the moment here. Oops. Okay, so I'm going to jack up the signal strength quite a bit. We'll imitate the strong signal coming in on the antenna as soon as I get everything redone here. Okay, this is a crazy strong signal now coming in on the radio. There it is again. 5.6, 6 megahertz. I had no notion of a hum there at all. Oh, Peanut, please. Absolutely zero impression of a hum. Let's try another band. Maybe it's just band sensitive. Where was it really distinct? I don't remember now. Let's try the 9 megahertz band. That's band number 4. Band number 4. Let's see if we can pick up. What's up with that? Oh, so the problem is this radio, the tuning knob keeps knocking the volume control knob, throwing me off too. Is that what was happening there when I was doing that? Probably was. It's probably all it was. Yeah. What a radio. What a radio. Okay, we gotta pick, we want to tune in something here. Oh, Peanut, please. I tried 10, but 10's got, who knows. Let's try 9.8. 9.8 megahertz. Signal strength down. 9.8 megahertz. Oh my God, Peanut, you're just killing me. Do you want to come up on the bench? You want to come up here? Yeah? Come on, come on, come on. Here, come here. No, no, don't go. Okay, you know what? I gotta go deal with my cat because he's telling me he wants me to go somewhere with him. Probably get him a drink of water. That's probably what it is. But I gotta go. I gotta stop right in the middle of this. Okay, I think my cat's all happy now. So, let's continue here. I'm just staring at the scope there for a moment. No hum, hey? Let me blast it with a signal. I think did I try this already? Let's just try it again. So now you can hear the hiss level has disappeared, which means the gain of the radio has been pushed back by the AVC. So there's a strong AVC voltage there, and we should be able to actually see it on the scope. So this is on 2 volts per division, and we're about 2.5 divisions down. It's about 5 volts. Oh, did you see that? As I tuned in, this thing for a moment jumped way down. Now that could just be because the AVC capacitor took a moment to charge up, but it was quite dramatic. It's a very sudden movement here. Yeah, I think that's just the pull-in on the oscillator. It'll probably pop out too then. No, just drifts out slowly. Okay, let me come back in on it. Very sudden. Come in from the bottom, there's a sudden pull-in. So ultimately what I'm going to do with this radio is align it once again in its entirety using the sweep generator as much as I can. I can only use it on the AM band, but at least that'll give me the IF shape. Maybe the IF shape is wrong and that's why it's doing this. I don't know. Kind of odd, but no hum. Where's the hum? Okay, I'm going to hit it with a stupidly powerful signal at this point. It's just zero hum. There's no hum in the line here either. And there's never a hum. Part of what I'm hearing here as I tune in and it suddenly grabs on, at that moment I believe the AVC voltage goes way high and then it quickly comes down as the AVC capacitor charge. That doesn't actually make sense, does it? That's the wrong way around. Oh well. No hum. We're gonna have to tune in some station here. Where are we? We're about 10 o'clock in the morning. Well, my guess is somewhere on this 9 megahertz band we're gonna pick something up. So let's try it. We will see what we get here. I'll take off the signal generator, bring on the my external antenna here. Ground to the ground. Let's try that. Well, that's pretty interesting. So when I ground my antenna to the chassis, this is what we hear. And I do the same thing, only to the ground terminal. Wow. Cool. Uh-oh, I wonder what that means. I have to study the schematic a little bit, figure out what the difference is. Okay. So we want to just tune around and see what we can find here on the radio to listen to. That's the volume control going out of control there. Well, that's 10. There's absolutely nothing there. Yeah. Hum problem. Not a hint of it. Maybe a strong signal. Strong, man. We need something strong. Nothing strong. We'll take a shot at 15 megahertz. See if we can get up there. That was interesting in itself. Okay. Now, there's going to be somebody strong here. I kind of doubt it. Let's see. We're not even to 15 yet. It's 15. Right here. So I have to run and check my antenna now. See if it's really switched on in here. Just maybe it isn't. So hang on a second. Yeah, unfortunately the antenna is switched on here. We need a station. Well, unless I can find some very strong station here to... Let's try 11 megahertz band 6. It's interesting, as I switch it, you hear that Okay, so I'm easily fascinated by funny sounds there. So, okay, we're on the 11 megahertz band now. See if we can get something strong there.
مطالعات ښایي چې د استرالیا، اندونیزیا او اسرائیل په څېر هېوادونو سره په اقتصادي مسلو.
So, I'm not hearing this effect at all. Listen to this. Here we go.
ډېر ژر پیل شي، مګر دا باید په ګوته شي چې د دغو هېوادونو سره د محصولاتو، خدماتو او پانګونې سکتورونو تفصیلي بحث. د هند ستراتیژۍ د هالنډ تړون لاسلیک کولو دمخه مفصله بحث او خبرې کول دي او اجازه به ورنکړي چې د حساسو څانګو ته زیان ورسوي. په دې لار کې هندوستان به په نږدې راتلونکي کې د بېلابېلو هېوادونو ډلو سره د اقتصادي مسلو په اړه د خبرو اترو له لارې د اقتصاد د ښه کولو لپاره خپلې ټولې هڅې وکړي.
قدرمنو اورېدونکو، په روانو حالاتو سیاسي تبصرو تاسې واورېده. اوس واورئ د نن خپرونه د زړونو اواز چې زما همکار هریندر کمار سواتی تاسو ته وړاندې کوي.
Well, I'm getting zero of the effect here. This is typical, isn't it? You know, typical in the sense that when you want something to happen, it won't, and when you don't, it does. Well, what am I to do here after this?
ټولو اوریدونکو ته زه هریندر سواتی د خپلې خوا او د پښتو څانګې ټولو کارکوونکو لخوا
I think that might be Radio India, but I'm not sure. Well, all we can do is to do something useful. There's a tremendous amount of play in here. Oh, that's the volume control. I get fooled all the time by that. So let's take a look at the capacitor here. And what we're looking, let me turn it down. Okay, so what we're looking for is to see if the capacitor is moving as I tune the tuning knob, which you can no longer see. Watch the capacitor. I'm going to start wiggling the tuning knob. So you can see the pointer moving, but the capacitor is sitting there. You can hear it's not tuning. If I go a little further, there, moved. So the play can be springiness in the strings even. The way to combat this is to make that capacitor easy to turn. So I think lubrication of the capacitor is the way to solve this, I think. Something I don't think I've done at any point yet in this radio. Let me just change the lighting here. Blasto. So now how to tell if this is the sticky point is a little tough. I'm going to shut the set off because this is all mechanics at this point. And I'm going to try to turn the wheel and feel the resistance. But you know, I mean, it's crazy to do this because the wheel is in all those strings. Yeah, this isn't going to work. We'll have to go on an assumption. I'm going to get some, I'm going to swing this around this way. Get some of my favorite stuff. We're going to throw a little WD-40. First I'm going to try to get down. Usually there's ball bearings in these. I don't see any ball bearings up here. I'm going to tune the radio to close the capacitor, get it out of the way. Oh yeah, there's the ball bearings in there, of course. And then in here are often spring-loaded sliding contacts. You see this brass piece that's bent over here? There's another one here. These are actually spring pieces, springing outwards and pushing on the brass rod here, just right in here. And these can benefit from a bit of WD-40. What? Just the tiniest amount in there. And then we have a bearing on the back here. Again, if you think about the ratio of the size of the wheel, size of the wheel versus the bearings you're pushing against, there's a lot of leverage here. So now, did that help at all? So I'm going to open the capacitor a bit. Now I'm going to do that back and forth thing and see if I can get a real good look at it here. So I'm going back and forth. The pointer is moving on the radio. The capacitor's not moving. Or is it? I'm watching the big wheel here where the movement is easiest seen. No, I think there's still a significant sticking spot. So next thing we'll do is we'll look at the drive strings down here. I think what we're just going to find out is there's so much string in this radio. It's just too much stretch and play in the string. So here's all these strings. Let's see which one's doing what. They're all involved with the pointer or the big wheel. Now I'm going to wiggle the control back and forth. So I can see again, this is moving a little bit. So this is the string that has to move this. So what I'm doing now, I'm applying pressure a little bit so I can feel it with my finger, and then I'm working the knob. So I can feel the pressure going up and down. So looking right in here at that wheel. Smaller wheel inside there. It's fused, right onto this big one, so it can't not be moving. The fact that the pointer is moving indicates this is all moving. I cannot move the tuning knob at all without moving this, so it's working just fine. The problem is the other one. You have a small wheel driving this big one over here. I don't think it can be overcome. I think that's just the way it is with this radio. Too much string. Let's try this other one. Yeah, so I can feel the tension going up and down. I wonder if I increase the tension on this, but I'm not going to do that. Maybe increasing the tension would solve this, but I'm not going to do that. That's it. It cannot be fixed. It's inherent in the radio. That's, for a high quality communications grade receiver, that's a very, very serious problem. It really should not be like that. The very best communications receivers, they would never have strings in them. They'd be gear driven to ensure that there's none of this backlash. They even use the double geared spring loaded system to try to, and a lot of radios do, to try to compensate for any amount of play in the gears if they're using gears. So this radio actually falls really short because of the massive amount of string in it. Yeah, I can't fix that. So the next deal is, what is the next deal? The next deal with this guy will be another run at the alignment using more equipment, especially getting the IF looking right using a sweep generator, and just run through the alignment one last time. But the radio is working really well, and I will attach that video from last night, and the hum is really, really apparent, so you won't think I'm crazy. And I'm going to go off and enjoy the rest of my very cold day here. It's a very cold day in Aurelia. Okay, so thanks for watching, and I hope you enjoy the next little bit that's coming. Well, hi, thanks for joining me in my shop here tonight. It's 10:15, In the evening, my other radios are picking up shortwave really well, so I'm going to give this radio a chance here to prove itself. So what I'm going to do, I'm just going to run through the bands. I'm not going to say much at all well, we'll see if that's true. I'm going to try to not say too much at all. And we're not going to look at it this way. We're going to look at it this way. There. Okay, let me switch it on. Let me turn the power on too, that might help. There we are. Okay, band 1. Okay, so it's a little hard for you to see it, but I'm manning the volume control down here at the same time I'm tuning. So just tip the radio a bit. Now let's go from this band. Let's just carry on with this. We'll jump up to band number 5. It's 3.9 megacycles too. We're at the wrong end. Okay. Close your ears. Okay. A bit of a preview there. Now, unfortunately, the volume control is sticking here, so I'll try to keep the volume as steady as I can. pretty weird. I guess you better man your volume control too here. So that was kind of interesting. Get some strong stations coming up here. That's an odd frequency for a broadcast.
Subtitle is Unlocking End Times Prophecy Through the Lives of God's People in Israel. To see how God's master plan is revealed in the 7 feasts of the Lord. And Pastor Ray reveals significant prophetic patterns discovered in the lunar cycle. Dr. David Jeremiah says in the book, while on vacation, I had the privilege to read Ray Bentley's book on Israel. I am not a stranger to the Holy Land, having been there many times. But I learned so many things about Israel and God's people that I did not know. The book reads like an adventure story. It causes you to look over your shoulder at God's continued blessing upon His people and to look forward to the many prophecies that are yet to be fulfilled. When you are finished with this read, you will want to book a tour of Israel. Get a copy.
Angels gather together His elect from the four winds, from one end of heaven to the other. Now learn a parable of the fig tree. When his branch is yet tender and putteth forth leaves, ye know that summer is nigh. This generation shall not pass till all these things be fulfilled. Heaven and earth shall pass away, but my word shall not pass away. But of that day and hour knoweth no man, no, not the angels of heaven, but my Father only. But at the day that Noah were, so shall
That's a powerful signal there. Don't want to get a copyright hit, so that's the best so far. Okay, so we'll go from 8 go up to 9.2 here on band number 4. the wrong end again. Let's just go this way this time.
You said that the state called you a bad
Oh,
parent.
where's that hum from?
Right. So exactly. We don't
Here's a
want
hum
that.
vary with the AVC.
I would tell you, get in touch with a lawyer, a friend. And you don't even say, look, I got this problem. That the kids are in school. What if I pull them out? Can they accuse me of being a bad parent? What are my rights?
Yeah, the garble is the hum.
Because
It's the
laws
same
vary
hum.
from state to state, and I
Gotta find that.
probably already issued guidelines, but let's face it, hospitals have large face masks to protect from splatter. Hospitals have, N95 masks.
So we'll go to 11 now. 6 band 6. Band 6. So just getting a little bit high for this time of night. No, nothing. And then only because I'd like to say I did it, we'll go to band 2. Should get nothing up there. Oh. Teletype. Oh, you know what? I hit band 1 by accident. We're in the ham band. And that's ham radio guys using what? That sounds like radio teletype. Okay, let's go to band 2. Band 2 is kind of freaking out there. Okay, band 2. Might be one lone station up here. No. No, might be getting all's quiet. There's nothing in this part of the band normally anyway. Okay, there we go. We might as well. What the heck? Let's see what's on the AM radio band. Now the radio's tipped up on its side. Hard for me to believe, but I found it didn't receive well on its side. It's a little far-fetched to understand why. Let's just go through.
At the time, we both agreed it was the right move. I think we
590.
continue to echo this.
640. It's just because the antenna's on its side. Be more than just being on its side to be like that. Oh. Let's try this radio out just for a quick listen.
The passer and all of that during the practice week. So the cool thing was during the week. Ball at this strike with the track.
So the fact is, it's very tough for a radio to receive here in my shop. AM radio like that. So, what can you really expect out of a radio like this? I think I could expect it to do better. I think it could do better. Okay, so that's the demo. Great. I got to deal with that hum. That's for sure.